So guys, we will start in a minute. So ask your friends to join first. No, no, Naman, attendance form will be shared. Till now it has not been shared. Prakar, from attendance form you will get certificate. If you not submit attendance form, so how could we know whether you have attended the session or not? So hello, good evening everyone. Welcome to IEEE. Welcome to IEEE DTU TechWeek 2022. Hope you are enjoying till now, enjoying all the session that we have conducted. So as you are familiar, we are today conducting session on machine learning. Some of you might be already familiar with what is machine learning, and some of you won't be. So that's not problem. We will cover everything from the basics. So yeah, let's get started. Next slide. First of all, let me introduce ourselves. Myself, Shitesh Kumar, first second year computer engineering, and with my friend Abhinav Agrawal, second year electrical engineering. We both are going to be mentored, both going to be your mentors for this session. So next slide. Today's agenda will be, we will cover the following in our today's agenda. First up, will we see what is artificial intelligence and what is machine learning and deep learning, how it is different, or what how it is similar, and then we will look at basics of machine learning, its application, and in application in today's real world. Then we will see the classification of all the machine learning algorithms. Further, we will look famous algorithms of machine learning, regression, and classification. Then we have 2-3 fun session of ML. Uh, Hope you will enjoy that. Uh, then comes our interesting part of our webinar. That's like linear regression, logistic regression, and the neural network. And we will conclude our session with a code quiz. So yeah, hope you will enjoy the session. And if you have any doubt, you are free to ask in the chat box. So let's get started. First, AI and ML as its subset. Next slide. So AI. If I ask you what is if I ask you if how you identify things, like if I ask you what is this, it's a mobile phone, cool, or how you identify with your voice, with your visual perception, or if somebody calls you, how do you identify who is calling by their speech or speech recognition, or in other words, I can say by your brain, by your intelligence, you can identify things or others' voice. So artificial intelligence is nothing but giving that intelligence to machines so that they can work on so that they can perform tasks that require human intelligence. In layman terms, I can say that it is technique of getting machine to work and behave just like humans. So it is written like that. So what is machine learning? Next up comes machine learning. Well, machine learning is nothing but a subset of AI that enables machine on working and making decision on their own by feeding them data. And just like we humans learn from our past experience, data works for machine like that. It learns from its data, just like human learn from its past experience, its mistake, and don't repeat in the future. Just And just like that, you can understand machine learn from its data. We feed them, it processes that data, learns that data, and give us output what task or we have to perform without being explicitly being performed. Then comes deep learning. Deep learning is nothing but just a subset of machine learning that based on the construct of neural network algorithm that helps us to solve complex problems. We will see neural network in our webinar only. So you can see both these three terms are all interrelated to each other or connected to each other. So yeah. Next, Abhinav will continue from here.
So hello everyone. So we will be talking about general technologies that we use while we learn machine learning. So starting from Jupyter and Anaconda, these two are software that help you create an environment in your own laptop or any system that you are using, so that you can create machine learning algorithms. Next, we talk about GitHub. GitHub is a version control system that helps us to create new versions or go to previous version of your program, and helps in team collaboration. And then Python is an open source programming language which we'll be using throughout the machine learning. And Colab is a Google tool which is a cloud based, uh, you can take as a cloud based server, which helps to compile your machine learning algorithms without your laptop RAM being used. Means the Google server will provide you a RAM to compile your program. And TensorFlow is an again open source deep learning library that we will be using for our machine creating machine learning algorithms. Then comes these libraries called NumPy. These all are used for data science as well as machine learning. So starting with NumPy, it is used for numerical computation. Scikit-learn is used for machine learning, whereas Seaborn and Matplotlib are used for basic plotting and visualization patterns for graphs, making 2D and 3D graphs and other stuff. And Pandas is used for data manipulation. So let's start with what is a formal definition of machine learning. So machine learning is a field of study that gives computer the ability to learn without being explicitly programmed. So let's understand it in easy language. So basically, you train a machine like a student, and after it is being trained, it can automatically solve problems. So it is being trained on some data set, and it can solve a new problem which is not in the data set. So we can say that machine has been trained, machine has learned something new. Uh, Programming versus learning. So we say in basic programming, we give a set of instruction, rules the data to the computer, and it performs the task and gives the output and the answer or the answers. Whereas in machine learning, as specified in the diagram, you can see that you are giving the data and the output. Means you are giving, for example, you are giving a picture of a cat and you are telling him it as a cat, and the machine learning algorithm will itself define a program to identify a cat next time you show them. Applications of ML.
Uh, First up is image recognition. First application comes is image recognition. Many of you have must have used .NET app. So for finding the solution of any particular question. So what does it do is it is generally scan for that you generally scan a question and it finds the best solution, best suited solution for it. So in that also image recognition or machine learning is used to find your best suited solution. Another example you can take is a face recognition on also face unlock in that is used in your mobile phone. It is also one of the example of machine learning algorithm. It recognizes your face and face image recognition is used in that. Another one comes is jet recognition that you will study in neural network in today's slide only. Next slide. Next comes is voice recognition. Voice me- Abhinav? Next comes is voice
Okay,
recognition.
so let's talk about voice.
रुक जा.
Good.
Many of you must all of you must be using Alexa, Google Assistant, Pronta. So all how does it work? It is working on machine learning. We are training all these models beforehand by all the human dialogues and it learns from that all the data set. And when we ask to perform anything, like we ask Alexa to play any song, we have trained such that if we ask anything, it already knows what the user is asking it, and it automatically search and plays that song. So yeah, next.
Okay, so we saw two major application, that was image recognition and voice recognition. So there are many other applications also, like recommendation system. So we all use Facebook, LinkedIn, or Amazon, or many other websites like Spotify, Netflix, or Google. So what these do is they recommend us things like LinkedIn recommend us job, Facebook recommend us friends, Amazon recommend us products, and other things as the platform suggests. So how do they recommend, and they know our what do we interest? So they just take our data. So they have a lots of data, many people data. So they combine it and see what are the similar people that like us. For example, let's say I bought a Facebook, oh sorry, pen on Amazon. So Amazon take all the data of the people who bought pen and see, look that a person who was buying a pen also bought a notepad. So he will recommend me a notepad simultaneously. Similarly for LinkedIn, so if I applied for a let's say software engineering job, so it take the data for all software engineering jobs and say that they also applied for data science jobs. So he will recommend me data science job, and similarly for every other platform. The other comes to optical character recognition. So all of us might have used cam scanner or Adobe Lens or anything that we use to scan our papers. We might have scanned our papers and the image becomes enhanced so that it is readable and scanned, means good quality image. So it is done through a machine learning algorithm that is running in back end of the applications. So it is used to create OCR and extract the text from the images. Another big application is self-driving cars. So, as you can see, it is a Tesla self-driving car. So, for this was a car that was trained on a huge model of roads, training set, and driving angles. So, as you can see, after good training, it can drive on its alone without any assistance. So, next, we come to natural language processing. As the name suggests, it means the let's say a lot of text is written and getting the information from the text and understanding the feelings or emotions behind the text. For us as a human, we can easily understand that if it is written, he was happy. To me, it is happy, matlab, positive vibes kind of thing. But for natural language, for machine learning, it is not that easy. So we use a technique called natural language processing, where we can understand the difference between different type of languages like happy, sad, or it is also used in anti-spam techniques, like that the thing written is spam or not a spam. It is widely used by YouTube and other platforms also. Okay, so let's come to the interesting part. That was fun with ML. We will be having three such apps for you. So the first one is the machine. We looked at the first application was object detection. So we will going to see an object detection application here. So this is an app I have created for you all. You will get the link in the chat box. Okay, should we say? So all you all can open that. So it will take a time to load because it will load the machine learning model at your system. So let's wait till it get loaded. Yes, you can see the model has been loaded successfully. So you can click on enable webcam. So after you can click on enable webcam, you can see that it is detecting me as a person. Oh, obviously I'm a person. So it is correct detection. So you can try with different objects like I have my notebook here. So let's try it with the notebook. So it is detecting it as a book, and you can detect the person in the book also. So book and the person in the book. Oh, so it will also work with my cell phone. So it is detecting it as a cell phone. Yes. Uh, Yes. Cell phone with a confidence of 90%. So you can try it with all the objects that you have in at your home. It will not work with all of them, but it will work with most of them commonly used object. So let's get back to the presentation. I think Kshitij will continue from here.
I will continue from here. I will present my screen. Now let's move forward to classification of machine learning. Machine learning is broadly classified into three categories. That is supervised learning, unsupervised learning, and reinforcement learning. First we will see supervised learning. What is supervised learning? Supervised learning is a machine learning algorithm in which we provide a sample of label data to machine learning system in order to train it, and on that basis predict output. Now you will ask, sir, what is this label data? So you understand like this. Suppose we have various types of shapes: square, rectangle, triangle, hexagon, polygon. So how you identify the shapes? By their names. Like if you have a round figure, you can say it is a circle, or if you have a uh, shape with all four sides equal, you can say it is a square. Or similarly, if you have all six sides equal, you can say it is a regular hexagon. So labeling data is just nothing but we are associating a name, we are giving a name or tag to it, so that we can identify. How can we identify it? Just naming it, you can understand like that. Or you can see, like, take an example of two phones. One is iPhone and another is Android phone. So how you identify, how you call these two phones as different? You can say one is you gave two labels to them. One, you say it is an Android phone, and another it's a iPhone. So you are basically adding a label. So label data just means you are just adding a name to it, so you can identify or say how what it is. Then system creates a model using that label data to understand the data sets and learn about each data. Once training and processing are done, then we test the model by providing a sample of label data and predict its output. We will see in the next slide how it is done by an example. Supervised learning, it can be further classified into two types of algorithms. First one is classification and regression algorithms. Let's see an example. Suppose that you have three different types of coins. Say one is ₹1 coin, another is €1 coin, and another is $1 coin, right? Now, and each coin has three different weights. Like 1 gram, ₹1 coin has 3 grams, €1 has 7 grams, and $1 has 4 grams. So we can say here that the weight of each coin is a feature of that coin, right? We can say it like that. The weight is the feature of the coin, and the different currency like ₹1, dollar, and euro are there labels. We are identifying, we are naming them like by ₹1 or $1, €1 are there labels. So now what we have to do, we have to build a model for predicting the value of by predicting the type of the coin by giving them the value, by giving them the weight. We have to identify what type of coin it is. So for this we develop a model in which we provide this data to a machine learning algorithm, a machine learning algorithm of supervised learning, and it identifies which label is associated with which coin. Like 3 gram is associated with ₹1 coin, so it learns it. And uh, when we test any test for any coin, any type of coin, like we test for ₹1 coin, we provide it to the system, and it checks if it is a what feature is of the coin, or what weight it is of coin. What So if it's check it is of 3 gram coin, and then it system can say, the machine can say it is a ₹1 coin. Similarly, if it would have been a 4 gram coin, then it can identify as €1 coin. So you can see in supervised learning we are using label data to identify, to predict the outputs. So yeah. That's for supervised learning. Next comes is unsupervised learning. Unsupervised learning is a learning method in which machine learns without any supervision. Training is provided to the machine with the set of data that is not been labeled or classified or categorized. So it is just different from supervised learning where we are using labeled data. Here we are not using unlabeled data. So you will say now, ask now how then we will identify it. That I will explain to you from this an example. So suppose you have a cricket data set of various players of their scores and their wicket taken. Now, now from that data, we plot a graph of that of these players, and we can see that there are there are many players. We can see on the screen that on plotting on graph there comes two clusters. One cluster is of players that score more runs and take less wickets, and another cluster is of player that take more wickets and score less runs. From looking at these two clusters, what you can say, this cluster can be of batsmen, right? As they score as players, these are players that score more runs and take less wickets. And similarly, from looking at this cluster, what you can say, these will be of bowlers, as they are taking scoring more runs and taking less runs. But an interesting point to note here that beforehand we are not labeling anything. We are not labeling that clusters that beforehand that if player scored more runs then it would have been batsmen, or if it scored more runs it could have been bowlers. So you can see we are not labeling earlier. But from these, by looking at these clusters only, we can tell these will be of batsmen and these will be of bowlers. So you can see the difference between supervised and unsupervised learning, and that here we are not using any label data to predict the output, and as opposite of supervised learning we are using the label data. So you can also understand that you can another point to note here is that in supervised learning we provide input and output of the data at the same time, when we have to at the starting of the algorithm, at starting of that process only. Whereas in unsupervised learning we are giving only input of the data associated to it, not the output that we have to predict. So that's from supervised and supervised learning. Next comes is reinforcement learning. Reinforcement learning is a learning method based on the method of feedback. It is a uh, it in which a learning agent gets reward for each right action and gets penalty for each wrong action. You can understand like that when you watch any movie or go to any restaurant. If you don't like the movie, you give a negative review to the movie or give less ratings. Or similarly, if you like food in the restaurant, you give a good feedback to the restaurant. So what happens from the that feedback? If it is a wrong feedback, then the restaurant owner will try to improve its quality of the food, and then next time it will improve it. So similarly for the machine, if we provide the feedback to the machine, if it is predicting the right input, then it's fine. And if it is predicting the wrong input, we provide the feedback to improve its performance, so that it improves in future. It would inform, uh, predicts more better and with more accuracy. So the, that's all from the reinforcement learning side. Next will classification will be covered by another Abhinav.
Uh, So, firstly, there are few doubts in the chat that it is failed with something and mirror कुछ ये बता रहा है. So yeah, it is a algorithm that I have trained on a very low data set. So it is not, I might have not given the data set for pen or chair. So I have might have given it for mirror. So if we create a big data set, so it will not load in your web browser. So when you will be needing a good thing for running it on your web browser. So it is a small data set model, so that's why it is not doing with every object. Okay, अरे पिछली स्लाइड पे है. Okay, so let's start with classification algorithm. So the image recognition is the classification algorithm only. So classification algorithm is a type of supervised learning technique that is used to identify category of new observations. So in classification algorithm, a program learns from the given data set or observation and then classifies the observation into yes or no, one or two, or the any criteria it is given on. It's like it will be 1, 2, or 3, A, B, or C, spam or not spam, anything. So the example that I given to you was of multi-class classification. So next slide. So we'll look about it. So there are basically two types of binary class classification. So in binary class, it is simple as the name suggests, a classification between two, means yes or no, true or false, 0 or 1, like this. Next. And in multi-class classification is that means more than two, so it can be 3, 4, or anything. So image recognition comes under the multi-class classification. So I have created around 80 classes in the model that I have trained, so it has specific 80 object set. Okay, next. So let's talk about training and testing. So the model is trained and also tested. So firstly, we have the data. Let's take I have 100 images of chair. So I will divide out of 100. Let's suppose, for example, I take 75 for training the model, and 25 I take for testing the model. So why it is important? Let's understand with the example of a maths class. So suppose I am the teacher and my model is the child, means the student who has to learn. So I have a book that contains the 100 problems, and I will give him the 75 problems with the solution, so that he can learn, practice, and understand what is the, like, questions will be like 1 plus 2 equal to 3, 2 plus 2 equal to 4, and other questions. So after it gets everything, means it get learned, so I will test with the remaining 25 datas. So why it is need to test with the remaining 25? The need is because if I will test with the 75 only, so as a human we might not be able to learn that, rote learn that thing, but computer rote learn that thing very easily. So if I give him picture out of those 75 only, so it will be a very easy job for the computer to test. So I have kept some 25 secret pictures that will be used to test the model, and we can verify that the model is working properly. And the confidence percentage gave us the ratio, means gave us the thing how the great is the model trained. Next. So here comes the second thing. It is a ML soundbox. So I will play it. So it is this will work 100% fine on everyone system. So it will have no glitch. So let me show you. So you have the link in the chat box. Everyone can open it. So I am sharing the screen. So as you can, it will also take some time to load the model. So it has recognized. Open the camera. It will load. Still loading the model. So on everybody's system, it will take time to load the model. After the model has been loaded at your end, so there will be a sound box displaying on the right hand side. So yeah, you can see the model has been loaded, and you can see a sound box. So what you have to do is you take your hand, and it is basically tracking your finger, index finger basically. So you can click left, it will go to left, and you can create any amount of any kind of sound that you want. So take it to now. So it is a simple app you can play. It looks like some virtual reality also. So hope you enjoyed, and you can play with this along the same. And there is a third one also waiting for you at the end, and that is the most interesting one.
Moving forward. So now the interesting point of our session begins, the regression. So you can now, those who are not paying attention also, so you can start paying attention now. That's the most important part of our session, regression. So if I ask somebody, ask you to predict what is going to be the future of tomorrow, so can you do that? So guess ही कर लो कितना ही होगा, 1 degree, 5 degrees, 5.5 degree, 10 degree, 12 degree, 13.5 degree, 15 degree, or it will be a continuous period, right? It will be not a discrete value like it is 0, 1, true, false. It will not be a discrete value, right? So what can we say? Or take an example of weight. Weight of a person. It is a weight of a person is also a continuous value. Like you can say 45 kg, 70 kg, 70.5 kg, 100 kg. It is not a discrete value. Discrete value is 0 or 1 or 2 of us, like that. So that's where, so we have now model to predict the value of a continuous value output. We have to build a model for predicting continuous value output. For that, it is where regression helps us. The regression comes in picture. We can predict the value of continuous value output through regression algorithms. That's where regression helps us, because as we have seen, regression is predictive model. Like here, it is like you can see here that it is predicting the temperature. What will be the going to be temperature tomorrow? So how can we judge our model whether it is predicting right or wrong? So accurate data or not corresponding to how it could be. So we can predict by the error our model performs. Model does. The more the error will be, the less that model will be preferred, right? Less the error, the more accurate will be our model. So we will judge our regression model based on the criteria, the less error that it performs. So yeah, that's the basic concept of regression. And we have many different models of regression models. That simplest will be the simplest is of that of linear regression that we are going to cover in this session. So yeah, let's get started. Before moving to linear regression, first we see two small terms, that is dependent and independent variable. From the name, it suggests what will be a dependent variable. A variable whose value doesn't change by defect of other variable of our consideration, and that can also change the value of other variables that are dependent on it. It is also called the cause of our cause, and in our notation it will be denoted by x. Next comes is dependent variable. A variable whose value change when there is any manipulation in the value of independent variable is called the independent variable. It is denoted by y and also called effect. So what these two terms are, you will more clearly understand with this example. Suppose that um, you have crops and rainfall. So for better, so you can see crops is directly dependent on rainfall. Like if there will be more rainfall, the better will be the yield of crops, right? And vice versa also. Like if it has been a poor rainfall, very low rainfall, then the crops will be very low. So you can see the crops yield is directly dependent on the rainfall, whereas uh, rainfall is independent of the yield of the crops. Whether crop yield will be less or more, it is independent of itself. It is doesn't bother about that. So that's what is independent and dependent variables. Hope you get. Next come is linear regression. Linear regression, till now we have seen regression. It deals with a continuous data output, right? And we have to build a model that will predict that continuous value output, like in the previous example, we are predicting the value of the temperature. For predicting the value of temperature, we require a model that can predict that temperature. So linear regression will help us in that. So before predicting a model, building a model, what do you think first we need to do? To find the relationship between the variables of that models we are considering. Like in the previous example, we need to consider the relationship for better yield of crops to know. We have to consider the relationship between rainfall and the crop yield. The more will be rainfall, better will be crop yield. Or we can say in the previous example of temperature, for predicting the temperature depends on the various parameters like altitude, wind speed, ocean current, like that. We have to we should know the relationship between them, right? So for finding that relationship, this algorithm help us, linear regression, to find the relationship between independent and the dependent variables, or we can say input variables or the output variables that we are predicting. So linear regression performs the task of predict the dependent variable value by based on the independent variable that we are considering. So you can see here it is a data set, and we are finding the relationship between the between the data set by a linear line. So in linear regression, we are using a linear line to find the relationship between between the both the variables. So it is, that's why it is also called linear regression. Next comes is the hypothesis of linear regression. You will get scared by looking this equation, but you don't need to be. It is simply a y is equals to mx plus c equation, where h not x y and theta not and theta I one are just intercept and the slope values respectively. Yeah. It is just another way of representing a straight line, so it is nothing much. Don't get scared by looking this equation. Next comes how that a hypothesis comes. Training set learning algorithm hypothesis, how that hypothesis comes into picture. Suppose we have training data set of sizes of houses. This is the sizes of house and that their corresponding price. Uh, these are the house sizes and their corresponding prices. And now we have to build and when we pass this data set to our machine, our learning algorithm, it gives us the hypothesis how can we predict the prices of the houses. It learns from that data set and gives us the hypothesis how can we predict the prices of house. uh, so that's what it is, hypothesis. Just a function that help us to in predicting the output. We will see in more in the coming slide. First see the terminology and notations that we are going to use. M represent the number of examples that we are considering. Like here 4 training examples are there, so M value is equals to 4. The number of training examples we are considering. And we have seen earlier the input features, the size of the house, and by the output variable, that the target variable that we have to predict. Uh, Here it is the price, estimated price. X and Y in pair are known as a training example, and the complete set of all the training example is known as a training data set. And the theta and theta 1 and theta naught, as seen earlier, are the parameter slope and intercept value. And so our final goal is to predict the value of y, predict the value of y for a new value of x. So we provide a new train data, and we have to predict that value. So yeah, suppose we have a data set, and we have a hypothesis function, and we have to find the best suited regression line that we for this data set. So how we will do that? So let's see. Suppose that we have that data set. So we have to find the equation of line y is equals to theta naught x, theta naught plus theta 1 x, that best fits in our model, right? So we have to find a theta slope, solve any line, finding any equation of line. What we need is just two things: the slope and its intercept, right? So we can assume the slope value or theta naught value as intercept as 5 and slope value as 3. And we draw a corresponding y is equals to mx plus c line from it. And we plot this. We can see that it doesn't fit well in our data set. So we will try for another value of theta 1 and theta naught. Let's say we theta naught 2 and theta 1 has 1. So it will give us another equation of line. And it will, for similarly, we will try for other values of theta, some for the predicting best suited line for this. So for we have tried for different values on theta and theta 1 and theta naught, and we can see we get different lines that pass our data set. So our job is to identify which is the best suited line that passes our data set. So how can we say which is the best line? So as I also told earlier, the best line, what will be the best line? That the line that predicts our value more accurately will be the best suited line. So from the line we will get the least errors. That will the best line. Like take an example of this. We have this regression line, right? For x equals to 2, we are getting a value observed value that we from line that we are predicting x equals to 3, but from the data set but it is given its value as 6. So we are getting this error, right? Between the observed value, that between the predicted value and that actual value, that is what the error it is. And we have to and we have, for the best regression line, we have to minimize this error, all that error this is. So for that, so for that to happen, let's see what how it is done. Like for now, let's take an example of a line where the slope value is 0, theta 1 is 0, and intercept y is intercept is b. So it is a simply y equals to theta naught, or just say y equals to b line t, right? So now what we have to do is to find the errors for for fitting this line. We have to find the errors of this line. So we are taking this data point and the corresponding point in the regression line, that will be the error of this point. Similarly, for this point, this will be error, and for this for this line, this will be error. Similarly, for this line, this will be error. So we are summing all these errors like this and taking the mod as we are considering only positive values, taking the mod of all the values, and we have to finally get the function, and we have to finally minimize this function, right? For getting the best suited lines. So actually, what does we do is we don't use that function. Otherwise, instead of that, we use this squared function. I will explain what it is. Firstly, it is same as this. Theta naught x, we have replaced it with h of x. You can understand from this also, we have taken here theta naught equals to 0 and y equals to b. But for general theta 1 and theta naught, you can replace this theta by h of x, h naught theta of x, and then y is that corresponding output value that you have given in the data. So that is the same, and we have taken an average of all that errors. But you will see here we have done square of this function. We use the cost function, also called this cost function. So you will ask why we have squared this function. We have used the square function instead of earlier mod function. So the reason comes here that to the reason of this is that you must have studied, must have known that mod function is a non-differentiable function, right? And for finding the minimum maximum, you must have studied in earlier classes. So we have to first differentiate that function and equate its derivative to 0. We have to differentiate that function. Sorry. Differentiate that function, but the mod function is not differentiable, so it is not used. Instead, a quadratic function is used as it is differentiable everywhere. And also another reason is that when you will learn gradient descent in this session, you will see how it is very much more convenient to use a square function instead of other constant function or mod function. So yeah. So this is the error, and we have to let's say this is simply the same thing. We have to minimize the square of the errors now. Instead of the mod, we have to minimize the square of the errors. So how we will minimize this error? There are there are two methods. One is the normal equation method, that is the same as that you have learned must have learned in the previous 11th and 12th, 11th or 12th. That is, we differentiate with such differentiate the equation and equate its derivative to 0. And from that, by equating to 0, we find we get the points. We check the points with the maximum, but it is not preferred. It is computational more expensive than computationally more expensive. So it is not preferred in general. But it is also right way, but it is not preferred. It is expensive or not an optimal way to. Instead of that, we have a gradient descent algorithm for finding the minimum of the cost function. What is this gradient descent algorithm? So we will see what is this gradient descent algorithm. So till now, what we have, our hypothesis function h naught of x is equals to this hypothesis function h naught x is equal to theta 1 plus theta 1 x, right? And another is we know how to measure. Another is a cost function. We have know how to measure which regression line best fits in our data. We have now two things. and now we are just left with to estimate which are the best suited parameters theta 1 and theta naught for our regression line to predict the output the best predict the output. So for that we are using gradient descent. For that we are first plotting theta naught values on in x-axis and theta one y-axis and and cos function on z-axis. You can see more clearly from this figure. We have plotted theta naught on x-axis, theta one y-axis, and cos function on z-axis. So yeah. Now consider an example where we have considered a theta naught and theta one value of this data set. And for this theta one theta, we have to find the value for which this theta one which for which this cost function will be minimum. So basically we have to find theta one and theta naught for this point, right? So that our error would be minimum. So we have considered this point. Now how would we reach this minimum point? So if I ask you how would you reach here, in which direction will you move? uh, so in which direction will you move? Vertically downwards, straight downwards, right? For reaching here. And from here, what next step would be? Again, vertically downwards, and another again vertically downwards, and you will reach this minimum point, right? So now a question will come in your minds, sir. How you are telling we can move only in this direction to reach minimum? Why not this direction, or any other direction? So that is where gradient descent algorithm help us. It help us in predicting the telling it helps to tell the in which direction we have to meet to reach in order to reach the minimum. Uh, so yeah, how it is happening. You can see it. What it basically does is it finds the dy dx at that point, or the slope of tangent the dy dx at that point, or we can say the slope of tangent at that point. Like here we find dy dx or the slope of tangent at this point, and the slope of tangent will tell us the direction in which we have to move. Like here we find dy dx, it will tells in downward direction we have to move. In next point, again here we find dy dx point, and we will see in which tell which direction we have to move, and it is continuously doing that. What is this algorithm? You are finding dy dx at this point, and you are also updating that value at that theta at that point. Like here, if you are considering some theta or theta naught or theta one, you find the derivative at this point, and also update its value by moving in this direction. That's what it is doing, and it is constantly updating its value till the point we reach the minimum of this graph. Right? So and the size that we took in this step is called the learning rate, or the alpha, that is represented by alpha, that we'll see in the next slide. So basically, hope you got the algorithm. So now you will ask is how we are knowing whether by finding the dy with dx by finding the dy with dx at this point and moving in that direction, we are getting we are moving in the right direction, right? How you can say gradient descent algorithm is working perfectly fine. So for that, you consider the 2D figure of this diagram. So you can see the 2D diagram of this, or of that cost function. So if you consider any point, like you consider point first point this first you consider point here, and you find dy over dx at this point. So dy over dx, or the slope of tangent at this point, will be positive. As you can see, the slope of this line is positive here. So this term will be positive, and this term is positive. So you are subtracting a positive term from a bigger positive term, right? So basically, for reaching the minima is a point is much smaller than that is smaller than theta one, right? So we have to move in the direction of value of less theta one. जहाँ पे theta one की value छोटी होगी, पहले वाले theta one से उस direction move करना. So हमारा gradient descent भी तो वही कर रहा है कि हम dy by dx उस point पे find कर रहे हैं और उसको अपडेट कर दे रहे हैं वहां पर. तो वो इसी डायरेक्शन में तो जा रहा है. हम किसी बड़ी वैल्यू से छोटी वैल्यू सब्ट्रैक्ट करके वो इसी डायरेक्शन में मूव कर रहा है. So and again we find if we find gradient descent, if we reach here and again we find gradient descent, it will do again the same thing. It will again update the value of again update the theta one value so that we can reach at this point, right? Now you will say that take the point on another side, it will work same way. I will say yes, it will work same way. Now look at how it will be. If you suppose the point, take the point on another side of the graph. So how dy by dx at this point is what, negative. So this term will be negative, and negative and negative will be positive. So here you can see theta will be increase, and we have to, and हमें वही चाहिए कि we want the point that where theta and theta 1 and theta naught are greater than this point, right, for reaching the minimum of this graph. So gradient descent वही कर रहा है, it is simply doing that only. It is finding, it is it is updating the current values of theta 1 and theta 1 to the value greater than its current value, right? You hope you are getting what I'm saying. So you can again we find, if we find here again dy by dx and update its value. So again it will be moved to a point where its theta value will be, its value will be much greater. So at this, so we can see gradient descent is working completely fine, whether it's respective or a point we are considering. It always moves it from this algorithm. We always move to the minimum of this graph, right? You can see irrespective of where we take the point, it is it, the dy by dx and the minus will balance, I think, everywhere, balance things, and you will reach the minimum of this graph. So that's how gradient descent helps us. Now another question will comes in your mind. So how we are moving how we are taking the size of the step, like how we are from this time, this point or this point, how we are reaching, what would be the size of step, whether we can take a larger step to directly reach one minimum, or we take a very small steps to reach the minimum, right? How we are updating the value, that is decided by the uh, learning rate, or which is represented by alpha. So it decides the size of the step that we have to take in order to reach the minimum. So suppose if you have take, if suppose you take alpha too small. So if you take alpha too strong, too small, and if you have to reach a point of minima, it will do perfectly fine, but it will do a job, but you think it will be very slow, as it will take many steps to reach the point, as it is updating its value very slowly. Like here, here it is very slowly reaching the point of minimum. So it will be a slow process. So we don't generally use alpha as very small. uh, then can you use a very large value of theta, we can fastly reach at this point. Let's see if we take a larger value of theta, and we can reach that point uh, very early, compute fastly or not. So if we take a large value of alpha, the learning rate, the gradient descent can overshoot this minimum, or may fail to converge or even diverge. So what this line said to suppose you have taken the point here, हमने यहाँ पे point लिया, और हम इस एल्गोरिथम के हिसाब से हमने पॉइंट लिया और अल्फा काफी बड़ा ले लिया, तो ये एल्गोरिथम तो अपना काम परफेक्टली कर रहा है, वो हमें इस पॉइंट से ऐसा पॉइंट पे लेके जा रहा है जो इससे बड़ा है। लेकिन ऐसे तो हो सकता है कि हम इस पॉइंट पे बाईपास कर दे कि अल्फा इतना ही बड़ा हो कि हम इसको अपडेट ही कर दे, अपडेट ऐसा अपडेट कर दे कि वो इस पॉइंट को स्किप करके यहाँ पे पहुंच जाए, हो सकता है ना। तो that's it is, we don't take a larger value of alpha here. Similarly, if we have point here, and if we take a larger value of alpha, it will be decrease only theta. But if we have too large value of theta, it will decrease that by that factor. It will overshoot that will cross that minimum, and we will reach to another point on this graph. So you can see we can't take a large value of theta, alpha also. So what the value then we have to take of this alpha? So generally we don't take very larger or very smaller values. We take in between values, not very large, not very small, 0.1, 2, like that values. Okay, so hope you have got some idea of gradient descent. Now let's see this gradient descent with an example. Suppose you have taken this point with an animation. As we are moving more towards the minima, you can see the regression line fits more and more to our data point. So So you can see how that gradient descent algorithm works. As we are moving to the minimum of this graph, and the error comes, the error will be minimum. That data set best fits in our line. So yeah, that's what gradient descent algorithm is, and that's what is linear regression. Next up is logistic regression. And Anubhav will continue from here.
So hello guys.
Also, I'm sharing the attendance form in the chat box. You can fill it.
So let me take few doubts that were there. What is alpha? Oh, I think Kshitiz can cleared it after all. Okay. Okay. So let's start with logistic regression. So now you have gone through linear regression. It is one of the most simplest form of any machine learning algorithm. So then come logistic regression and neural networks. So we will talking a little bit about logistic regression here as we are short of time. So I will be giving you a brief and then we will be continuing the rest of the thing in upcoming SIGs. Logistic regression is similar to linear regression, but the difference is here that it gives us the answer in only two values, means a boolean value, either true or false, you can say, or 0 or 1. So it is generally used in binary classification, like if you have to predict any two out of two. Next slide. So this is the function that is used when we use the logistic regression. It is called sigmoid function. So next slide. So we fit the function, we fit our algorithm over this function, and the sigmoid function equation is given as you can see here. So its function has some properties, like you can see that when the x tends to infinity, the function will tend to 1, and where extend will minus infinity, it will tend to 0. So there is a threshold point in between, that depends on the algorithm, the data we are using. So after that we can just give to 0 or 1 if the, let's say, if the point that has intersection of the y-axis, the curve and the y-axis is that threshold point. So if any data that lies on the positive side of the y-axis will be termed as 1, and the negative side of y-axis will be termed as 0. Next slide. Okay, so you can use any of the email, either personal or DTU. So let's talk about neural network. Neural networks are major thing that in the machine learning. So neural networks are everywhere, in from machines to your brain, to any machine learning model is basically based on neural networks only. So neural networks are a set of algorithm modeled loosely after the human brain that recognize the patterns. Next. So this is our brain. So I mean, this is not our brain, but this is a neuron that is present similarly in our brain, and also we create something similar to this in our machine. So as you know, in every part of the body there are different kinds of neurons. They collect different type of data. Different data means like senses, taste, anything that they are information that they are collecting and taking it to the brain, the processing unit. So similar to our system, next slide. Similar to in a system, we have different neurons that take the input and then take the data to the brain, and we get the final answer. So let's take and understand neural network with the example of handwritten digit recognition. Next. So let's take example of a handwritten line. So handwritten line looks similar to this. We have zoomed it, and after zooming, we have converted it to a 28 by 28 pixel block. These 28 by 28 pixels means 784 neurons. We are talking about 784 neurons that are from which we are taking data. So next, so you can see the GIF here. So you can see we took the data and then we arrange them in a single line, and after we get the 784 input data, we put them in a neural network, and after we put them in a neural network, we got the next slide. So we got that our neural network as an input layer. 784 were our input layer, and the answer that we are getting is from 0 to 9. So that is our output layer. So the after the neural network algorithm, next we get the 9. So this is a hidden layer, means what is the thing that is going inside this and we getting 9. So mostly in the neural networks, what is going behind the networks is almost unknown to us. So but I have tried to explain a bit of that. Continue next. So how will a 9 be formed, or any other letter? Let's take a three example, 9, 8, and 4. So to make 9, we will need a 0 and a 1. To make 8, we will need a 2, means 2 O shape, O type shape, or similar shapes. And similarly for 4, we need these three shapes. Next. Okay, so I will present my screen. It will be more convenient. Okay, so we talked about this. So we to make 9, we need this 0 and 1. So in the neural network, if we think second last layer before the output layer, this is the input layer, this is the output layer. So anything between these are the hidden layers we call. So let's take the last hidden layer or the second last layer. So we might be getting a 0 and 1 here, and we will be passing it to the last layer and output layer, and it will identify that 0 and 1 is 9. So there might be confusion, 0 and not 0 and 1. Actually, it is oval shaped at the top and line, and it can also be a 6 also. So what we make it a 0 is it should be an upper end, and all these things are checked with the before hidden layers. So to form a 0, the third layer, means the second last layer of the neural network, can be divided because to make 0. Like 0 might be receiving by here by these four networks, these four neurons. So there might be a each you can see this is circle, means it is a logistic regression program going on each network. So lots of logistic regression with each and every one gives us such results. So let's at this unit we are receiving this one upper circle and a stick, and before the neural network we might be receiving many small pixels or design that we have qualified to make the circle and a stick. So it is in realistic way it is something like this going on in neural networks. Okay, so we have reached the last experiment means project. So we will be using this. So you all can try. So this is as the name suggests. Uh, if it is called machine learning, it should learn it. Why should we learn? Actually, it is not true. But let's, for example, in this example, we'll teach a real machine. So your system has been loaded with a machine after a second, or means depend on your system. So let's teach it machine. To that we have used given it is a three class classification. So we have used three variables A, B, and C. So let's teach A, means we give the data set to the machine for teaching A, means class supervised learning. We're giving labeling A and giving that data. So to do that, you have to click A. Let's say I click A 10 times and it will receive my face photo 10 times. So I give A 10. So I give it 10 data of 10 picture. When you click A, it will take a picture of you and give it to model. So now it's A. So let us train B and C also. Let me do this for B. So it will be, so it is B. And let us do similar kind of thing for C. And we are completing the, and we are completed with the model. So it was A. So let's say if, okay, we need some more B. Oh, sorry, I messed up it. It was C. And let's redo it because you cannot restart the, you will restart the machine. So let's again do it. Let's take A as this one and B as the normal and C as the right side one. So finally, this was a B, this was A, and this was C. So you all can try it at your end and with different things, like it can be you, your friend, you, your family members. You can also try it with objects also, not only face. So let me do it with notebook. So this is the first one.
Abhinav, your screen is not, your tab is
Oh
not
shit.
shared.
Oh, sorry everyone.
You have to do again.
So I will explain you again. So your model will it will come model loaded, and then the camera will enable. So you have to basically teach the machine. So to teach the machine, you are giving the data set. So the system is specified like when you click A, it will click the picture and give the data to the machine learning model to teach it. So let's say I teach a machine with myself only, leave any other object. So let's click A, and one data set has been given. So I will give a quality data set. So I will give 10 pictures. So click 10 times. So the A has been taught. So A has been taught with this similar kind of images. So now let us go with B, and we will teach B. So B is my left hand over my left eye, and let's do it similar with C, and it will be right hand over my right eye. So this is A, this is B, and this is C. So this is our machine learning model you created at your end in few seconds. So let us try it with another example also. Please, you can also do it with any other object that you have. Okay, so I will do again with that notebook. So let's do A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So after A, let me teach this book. And then finally this one with C. So let's test. This one was B. This is our A, and this is our C. So it is a three variable model, and you can explore with it at your home with any other things you want. So we are in the end of our session, and now it's time for the Kahoot, I
Kahoot
guess. Huh.
quiz.
So let's begin with the Kahoot. Everybody get ready. So
Yes. So
uh,
ask your friends to join also. We are, Abhinav says,
करो
share
करो.
your screen.
So I hope screen is visible. So everybody can join the Kahoot from that link
You can ask
or
your
enter
friends
the
also
code
to.
90088.
जैसे भी थोड़ा भी idea आ जाओ machine learning का.
Attendance link we will share. Till then you join the Kahoot. Attendance link I have shared again. So we have award for the winners. And what more? I will provide you with any of the machine learning course, or not any of the. I have two, three. So we will take it.
We will tell you everything in the SIG.
Mhm. So I request everybody to join Kahoot
To join it.
fast.
No,
Basic
first three
award is
winners
for
will be
first three winners, and
winners.
first three winners. So, and every third means if you get on the first three winners, when you will, if you join SIG, you prizes for every person, everyone who joins SIG. Means it is not compulsory, but we preferred.
You can join. IEEE is a very
Yeah.
good society.
Okay, so
The
hi
seniors
guys.
here are quite helpful.
Hi guys.
Like
My
like
name
here
is
we have
Priyansh
Priyansh
sir
sir.
here.
Priyansh sir here,
Hi everyone. So
chair of our future chair of our society.
अरे नहीं नहीं बात तो देखेंगे वो सब बाकी so just ऐसे इंटरेक्शन करना था तुम सबसे यार एक कैसे रहा आज का like so what you just experienced was the part of TechWeek initiative of IEEE DTU. तो इसमें अलग अलग डोमेन्स की अलग अलग वर्कशॉप्स तुम सब में से जिसने अटेंड किए हो
कैसा लगा IEEE का ML का सेशन कैसा लगा आज का समझ में आया
ML का
कुछ
सेशन कैसा लगा बताओ थोड़ा सा शेयर करो थोड़ा इंटरेक्टिव बनाओ सेशन
हाँ अब
मतलब
अनम्यूट कर
बढ़िया है, अरे ये
अनम्यूट
कौन कर रहा है?
अनम्यूट कर सकते हैं
चलो अनम्यूट करने देते हैं.
अनम्यूट करना है,
अनम्यूट करके बोल सकते हो, बोल सकते
थोड़ी
हो।
देर बात करना है
बताओ
उनको।
बताओ,
चलो अब दे दी
इंटरेक्शन कर
परमिशन
लेते
मैंने
हैं।
आपको।
ओके चलो
बढ़िया।
बढ़िया, तो नाइस। चलो बेसिकली तुम में से आई गेस कुछ आई ट्रिपल में होगे, कुछ नहीं होगे। ब्रीफ आइडिया देता हूँ। तो आई ट्रिपल नाम तो सुन लिया होगा, वर्ल्ड्स एंड यूज मोस्ट ओल्डेस्ट एंड बिगेस्ट सोसाइटी है, टेक सोसाइटी। एंड वही है, मेंबर बनने का बहुत फायदा होता है आई ट्रिपल के अंदर। अगर आप देखो हमारे पास डिफरेंट डोमेन्स से मेंबर्स हैं। वी हैव, इट कंटेन्स members from all the different domains, be it tech, non-tech, core, and also अगर if we just consider DTU, IEEE is the only society जिसके साथ बहुत सारे प्रोफेसर्स कनेक्टेड हैं। तो अगर तुम में से किसी ने ओरिएंटेशन अटेंड करी हो तो तुम्हें पता चलेगा कि एक्चुअली हमारे प्रोफेसर्स ने ही पिच कर दिया था IEEE। हाउ कैन वी बिकम मेंबर? रोहन शेयर कर देंगे डिटेल्स, गूगल फॉर्म शेयर
It
कर
is
देते
there
हैं
in
अभी
the
यहाँ पे।
description of our group. If you are in the group, I'm in
हाँ
TechWeek group.
ग्रुप में हो
Group
तो
discussion
description
में
में
you can
होगा।
pitch any of the member coordinators.
हाँ तो बाकी
Yes,
हाँ,
questions will come on the screen here. So there are 28 people. I request everybody to join. Means 4 of them are us, so it should be 24.
बाकी
I
लेट्स
will be
कंटिन्यू। सो
starting.
करते हैं अभी, हो जाएगा, कोई नहीं, आने दो आराम से, कोई इशू नहीं है। बाकी हाँ ऑब्वियसली तुम लोग अभी आए हो, तुम से फर्स्ट ईयर्स कितने हैं यहाँ पे?
सारे फर्स्ट ईयर्स हो।
अरे फर्स्ट ईयर्स ही यहाँ पे, नाइस नाइस। सो देखो सिंपल सी बात, तुम लोग आए हो, तुम्हारे दिमाग में होगा सर प्लेसमेंट कहाँ,
second year.
इंटर्न कहाँ लगेगी, प्लेसमेंट कहाँ लगेगी, है ना, हजारों सवाल होते हैं। सो IEEE DTU में हम लोग प्रोवाइड कराते हैं तुम्हें इंटर्नशिप प्रिपरेशन। हमारी होती है इंटरव्यू प्रिपरेशन बेसिकली हम बात करें। सो उसके थ्रू काफ़ी सारे बच्चे हमारे थर्ड ईयर जो है बहुत अच्छी अच्छी इंटर्नशिप बैक की हैं, प्लेसमेंट बैक की हैं बहुत ही अच्छी अच्छी कंपनीज में। क्योरफिट हो गया, माइक्रोसॉफ्ट हो गया। देन इंटरनेशनल सोसाइटी है, सब बेनिफिट्स होते हैं। वी हैव डिजिटल मैगजीन्स जो IEEE एक्सक्लूसिव होती हैं। अभी इसके बाद जो अगर तुम IEEE का पार्ट रहते हो तो जैसे तुम्हें टेक वीक में पर डे के हिसाब से अलग डोमेन्स की वर्कशॉप मिली, हम पर के हिसाब से फिर ये लोग कराएंगे। जो तुम्हारे जो करंट सेकंड ईयर से जिन्होंने ये वर्कशॉप ली है वही तुम्हें आगे करवाएंगे। और थोड़ा सा जो अगर तुम्हें हेल्प चाहिए किसी भी चीज़ में वर्कशॉप में वो करवाएंगे। हाँ कर दो। वर्क परमिट अगर हम बेनिफिट्स की बात करें तो POR जो है वो इंटरनेशनली अक्लेम्ड होती है, तो डेफिनेटली एज मिलता है। तुम कहीं भी जाओगे, किसी भी अपने CV में लगाओगे, यू गेट अ एज। 1000 रुपीज की है, हाँ यार 1000 रुपीज एक्चुअली द थिंग इज, तुम अगर गूगल करके देखो इट्स 27 USD। सो इंटरनेशनली इट्स 27 USD, बट फॉर ITU स्टूडेंट्स जो हमारे थ्रू जाते हैं उनको हम 50% का ऑफ दिलवा देते हैं। दैट बिकम्स अराउंड actually 1000 and no taxes, just 1000. So do join it and enjoy the benefits. Continue करो Kahoot के लो यार।
Kahoot से
Kahoot
हाँ।
Kahoot में भी बहुत सारे वो हैं
So let's
prizes।
तो उसमें भी काफी स्वैग्स हैं, खेलो।
So we are starting.
So the first question is, in learning what we give input to the computer. So you have seen the learning, what we give input in the learning.
If anybody wants to join, you can check the link, or the Kahoot pin is here 9908823. Okay, the correct answer was board data and input. It was specified by Kshitij. So next question.
7 people may get it right. So leaderboard, first up is
So
Ananya, second
by Varun and Adi. So I request at the end, anybody who will be at the top, take the screenshot and send to any of the mentors or the group admins that you are adding.
Second question is, what is the classifier in the machine learning? And the options are the algorithm, technique, or function, or the system that maps input data to the category and approach in machine learning, and algorithm in machine learning.
If you don't know, please guess. Okay, so
कैसे कर
answer
सकते हो,
was
कोई दिक्कत नहीं है।
हाँ,
क्वेश्चन नहीं दिख रहे? अच्छा,
so next one.
क्वेश्चंस यहाँ स्क्रीन पर दिखेंगे।
क्वेश्चन स्क्रीन पे दिख रहे हैं, यहाँ पे स्क्रीन शेयर हो रही है, देखो
अभी ना वो स्टार्टिंग ऑप्शन था।
क्या क्या?
Question. Question will be visible on the screen, and you have to select the option, and your end only option will be visible at your end.
तो
Right.
फिर से एक बार लिंक से दिख रहे हैं ना यार, क्वेश्चंस लिख दो एक बार चैट में.
फिर क्वेश्चन ही दिख रहा है.
तेरे को दिख रहा था?
मैंने ज्वाइन नहीं किया.
नहीं, तू तो पढ़ भी रहा है तो क्वेश्चन तेरे को तो दिख ही रहा था.
स्क्रीन से दिख रहा है, उनके एंड पर नहीं दिख रहा. अरे क्वेश्चन
चलो इधर स्क्रीन पे देखना है क्वेश्चन, और वहां
क्वेश्चन के
जाके
लिए
आंसर
ये
मार्क
स्क्रीन
करना.
देख लेना, ऑप्शन के लिए अपने स्क्रीन पर स्विच कर जाना, मतलब टैब स्विच कर लेना बेसिकली.
हाँ
ठीक है. सो अभी लीडर बोर्ड पर सबसे ऊपर आ रही है,
ठीक है.
सेकंड पर
सेटिंग
वरुण
भूल
है,
गया मैं लगाना.
थर्ड पर जिया है, अनन्या फोर्थ पर आ गई है, जो मतलब फर्स्ट पर थी. चलो.
So next question. Which of the following
Which
is not example of image recognition? So Google Lens, digit recognition, Cortana, face recognition. So I'm reading it also.
इमेज रिकॉग्निशन के कौन एग्जांपल्स नहीं है इनमें से? We have seen image recognition in our PPT also.
Cortana, yes. Cortana is voice recognition example.
Most of them have got right.
So Aradhya,
So
top.
Aradhya is joined the lead now.
So the next question is, in which learning method we provide labeled data to ML system for training? Supervised, unsupervised, reinforcement, all of these.
जल्दी करो, जल्दी कैसे करो. हाँ, 7 लोग ने गलत किया है. लेबल डेटा मैंने स्पेसिफाई किया था, सुपरवाइज लर्निंग में होता है बस. अनसुपरवाइज नॉन लेबल डेटा होता है.
चलो. अच्छा, आई थिंक थोड़ा क्वेश्चन में प्रॉब्लम आ रहा है. एक सेकंड में देखता हूँ अपने साइड पे.
क्वेश्चन बोल, माइक ऑन करके बोल सकते हो.
तो यार अभी बीच क्विज में तो सेटिंग चेंज नहीं हो रही है. तो क्वेश्चन यार तुम्हारे इधर टैब पे दिख रही है, या फिर ऐसा कर लो फोन से कर लो, मैं तुम्हें फिर से थोड़ा टाइम देता हूँ. तो अगेन यू कैन यूज द पिन, जॉइन दैट. यू कैन यूज योर फोन. ग्रुप पे भेज दिया था ना पिन? तो पिन ग्रुप पे भी है, वापस मीट पे भी भेज रहा हूँ. तो एक फोन से ज्वाइन कर लो और क्वेश्चन यहाँ पे स्क्रीन शेयर कर रहा हूँ मैं. ओके, एक बार जब
Ready?
हो जाए सबका तो रेडी. हाँ रेडी लिख देना. 3-4 रेडी आ जाएंगे, देन आई विल स्टार्ट अगेन. और कोई रेडी ना हो तो नॉट रेडी भी लिख सकता है, ऐसे नहीं है. तो आई थिंक एवरीबॉडी, मोस्ट ऑफ देम आर रेडी.
So now we can begin again. Start again.
Yes. Next, go to next question.
First, let's see the leaderboard.
Rohan
Adi
on
is
fire.
leading. Rohan भी खेल रहा है, second place है.
So next
So
question.
next question.
This coin example is supervised learning. What does the way of the coin represents?
In
Label,
that,
currency,
the
feature,
example,
none of the above.
the example of the coins that we have seen in the supervised learning, the video that we have seen. In that, what does the coin represent? So most of you have got it right. So, congratulations. टेस्ट सेशन अच्छे से अटेंड किया तुम लोगों ने, सही है.
चलो, so let's move to next question. So yeah, Chinmay top. Okay, great. So we will award top 5 because there was some error in the starting, so no problem.
What will be the value of the learning rate alpha? What can be the value of learning rate alpha? Yeah, 4
This
options.
permissible value means permissible
Default
values.
value 1000.
Or you can say generally used values. Okay, so answer was highly
Many
divided.
of you,
It is 0.5. So
many of you have done all
this
of
was
those. I know
explained.
that you will do
So
all of
means it is a very small learning rate. So if you use this learning rate, it will be very time-taking algorithm. Means it will take days and days to get trained. And if you use this, it will be overshoot case. So that's what. So Chinmay is still on the top.
Add a second.
Consider the plot below h naught x, theta 1 plus theta naught plus
By
theta 1
looking
x.
at this graph, you basically you have to tell the what are the going to be the values of the theta
So
1
a
and theta
hint,
naught.
you can just predict a value of 1 and use that to get the answer.
इन जनरल ग्राफ देख के बता.
हाँ, general. Oh, great.
So majority of you have got it right. Well done.
So again,
Chinmay is still on the top, followed by Haider and Kamal. Arif. Regression algorithm is used when output data is discrete. You have to tell whether it is true or false. ये सही है, 2 ऑप्शन है. नहीं भी आते तुम्हारे तो एक 50-50% प्रोबेबिलिटी है.
वो काफियों ने मारा. यार ये तो सिंपल था. कोई नहीं.
काफियों ने तुक्का मारा. शशि ने कर लेते ढंग से.
So ये चिन्ह थोड़ा नीचे. कमल एमएल. Nice. 3 fire.
Arif.
What is the use of matplot.lib? मैंने बताया था, याद करो. नाम से सजेस्ट करो थोड़ा क्या होगा मैटप्लॉट. ओके, तो काफी ने सही याद कर लिया. डेटा विजुअलाइजेशन के लिए यूज होती है. सो दिस हेडर. ग्रेट.
3 सब्स एंड टॉप 5 में है.
आदर्श इज द हाईएस्ट क्लाइंबर. तो थोड़ा भी आया नहीं और हाई क्लाइंब करो.
लास्ट 3 क्वेश्चन बाकी हैं. लास्ट 3. The gradient descent is the size in the gradient descent of each step is decided by. तो जो हम साइज लेते थे वो कौन बताता था? लर्निंग रेट बताता था. ट्रू और फॉल्स.
Great. तो easy question again. Good. True. So टॉप 5 ही खेल रहे हैं. और भी आओ यार नीचे से.
कोई कम बैक करो जल्दी से. 2 क्वेश्चन है.
So moving on to next question. Which of the following is binary classification? Look at the
इमेज
images.
देख के बताना है तुम्हें कौन से बाइनरी क्लासिफिकेशन है. काफी रोमांचक मैच. और जतिन पांडे सर इज इन द हाउस. सर कहाँ रह गए? आ जाओ यहाँ पर.
नहीं सर थोड़ी ना आएंगे, बच्चे के लिए. वो सो काफी अच्छा. छोटी सी चलो बट नाइस. ओके, तो चिन्ह मैंने कर लिया.
बस एक मेंटेन करना है क्वेश्चन के लिए.
हमारे
लास्ट क्वेश्चन है.
So last
कोई
question.
17 नीचे है क्या? अरे प्रकार
Which of the following does not give continuous
continuous value output. इतना टेंस हो गया खेल रहे प्रकार, ये टेंशन नहीं लेते. अच्छा, मतलब कौन से कंटिन्यूअस वैल्यू आउटपुट नहीं होगा? किसका? रन स्कोर का, वेट ऑफ क्वेश्चन का, तो
ये तो
रेस एंड
काफी
हाँ
तुक्केबाजी
डिस्क्रीट
हुई
वैल्यू.
है इसमें.
12 में नहीं तुमसे 20 लोग अभी भी खेल रहे.
Okay, so this was the last question.
So we will now see the leaderboard who is
ODI.
at the top. At the number 3 was Ari. स्क्रीनशॉट ले लेना सब अपने. सेकंड पर
And
चिन्मय.
top 5 वाले भी अपने स्क्रीनशॉट ले सकते हो. And ML Kamal M
कमल.
come back. Great.
लास्ट क्वेश्चन कमल एमएल.
Runner-ups
आगे.
Rishabh and Haider also take their
Haider.
screenshots. So we are done
भी
with
ले
the
लेते
quiz.
हैं. फाइनली जीत गया. कांग्रेस टू द विनर्स.
So
जतिन
hope
सर
you
आ रहे
enjoyed
क्या?
today's session. Voice on करना. अच्छा 1 सेकंड करते हैं. Okay, लो बोलो.
हेलो भैया.
हाँ भाई.
हाँ भैया, काश आपने ये सेशन थोड़ा पहले किया होता, क्योंकि एंड्रयू एनरे कोर्सेरा पहले मैं यही सब पढ़ रहा था, फिर आज पूरा रिवाइज हो गया मेरा.
बढ़िया है.
अच्छा एंजॉय से कर रहा था. हम भी उसी से हमने भी उसी से किया है. और मतलब सेशन कैसा लगा सबको? फीडबैक दे सकते हो.
बढ़िया था. मुझे तो बढ़िया लगा.
पांडे सर है पार्टी देने के लिए यहाँ पे.
पार्टिसिपेशन बहुत कम थी यार. इतनी कम मैंने एक्सपेक्ट नहीं की थी बिल्कुल भी.
आधी
हाँ,
भैया आधी क्लास ईजी की क्लास चल रही थी.
आज तो सबसे ज्यादा क्लासेस होती है.
अच्छा क्लास भी करते हो फर्स्ट ईयर में? सही है. हाँ सही है. फर्स्ट ईयर में भी क्लासेस कर रहे हो.
चलो कोई नहीं. जितने आए उनका ज्यादा फायदा होगा. बढ़िया.
मेरे ना पहले 2 क्वेश्चन में वो चल ही नहीं रहा था, तो मैं पहले 2 कर ही नहीं पाया.
अरे कोई नहीं.
अरे कोई नहीं, तो इसलिए तो 5 को दे दिया.
चलो भैया चलते हैं. ओके थैंक यू
Okay,
बाय.
ठीक है.
बाय.
ज्वाइन करना है ट्रिपल.
तो अगर कौन सा कोर्स मतलब अच्छा है अगर करना हो तो स्टार्ट?
एनजे
क्या
कोर्सेरा पर है. कोर्सेरा पे एनजे का कोर्स है.
अच्छा ओके.
उससे कर सकते हो.
इसका क्या करना है स्क्रीनशॉट
तो
का?
कोई यूडेमी पे
हमें भेज दो. हम
स्क्रीनशॉट देखो डीएम कर दो एडमिन्स को ग्रुप के, अगर तुम उस
हाँ.
ग्रुप में हो देखो, या फिर किसी भी कोऑर्डिनेटर को भेज दो, हमें भेज दो चलेगा.
अच्छा ओके.
हार गया प्रखर. यार प्रखर हारा नहीं है यार.
अरे तुमने तो ज्वाइन नहीं किया था. हमने तो अपने टाइम पे सेशन भी नहीं अटेंड किया था ये सब.
तो सीखने को मिल जाए सबको. सब सीख गए. चलो तो जो जाना चाहता जा सकता है. वी आर डन विद द सेशन.
कॉलेज ओपन होगा बीच सेम में यार, पता नहीं यार.
हाँ वही
अबे
हो
तो
सकता है. तैयार ही रखो.
चांसेस तो रहेंगे.
पोजीशन का स्क्रीनशॉट भेजना है किसी को?
हाँ जो भी मतलब तुम्हारी पोजीशन थी, वो अगर तुम टॉप 3 रनर अप में थे तो डीएम एडमिन्स को डीएम कर दो ग्रुप के, अगर तुम उसमें हो, या फिर देखो मेरा इसका नाम होगा.
अच्छा ठीक है ओके.
So you will get your reward after the TechWeek get ended.
मैंने ग्रुप ओपन भी कर दिया. तुम ग्रुप में भी डायरेक्ट भेज सकते हो.
हाँ ग्रुप में डालना चाहो तो ग्रुप में डाल दो. चलो
ग्रुप में डाल दें.
ग्रुप में डाल दो.
सही.
बढ़िया पढ़ाया इन लोगों ने. मुझे बताओ.
अच्छा ये इनका इंट्रोडक्शन जतिन सर, ये हमारे सर हैं और हम तुम्हारे सर होंगे.
अरे
दो फीडबैक दो इनका. मैं लूंगा ही. बताओ कैसा पढ़ाया इन लोगों ने.
अच्छा पढ़ाया, पता है एक्चुअली अच्छा पढ़ाया. मतलब मैंने यही अटेंड किया है सिर्फ, और कोई नहीं की. मतलब वो मैंने मतलब ये काफी अच्छी लगी मुझे. मतलब मैं शायद अब एमएल ही करूंगा.
अरे वाह अच्छा लगा. ग्रेट यार.
देख रहे हो
मतलब ऐप डेवलपमेंट वाला देखा थोड़ा, वो उतना मजा नहीं आया. तो ये बढ़िया.
वो तो कोई बात नहीं. वो तो
काफी सही सीनियर है.
नहीं मैं तो हूँ IEEE में.
अच्छा
है.
हाँ मैं ऑलरेडी हूँ ग्रुप में भी.
तो ये सर के पीछे पड़ जाओ. यही कराएगा ऐसा ही.
अरे मैं कुछ नहीं करूँगा. सीनियर से है जतिन सर है. अरे हाँ कांटेक्ट हमसे कर सकते हो. अटेंडेंस फॉर्म में हमारा कांटेक्ट है. जब भी कभी भी कर सकते हो. कोई दिक्कत नहीं.
सही.
ठीक है. सब IEEE ज्वाइन करना. मिलते हैं.
तुम लोगों को
जतिन सर को
रिक्रूटमेंट
पकड़ना.
फॉर्म भेजा?
अटेंडेंस फॉर्म सबने फिल कर दिया ना?
नहीं, रिक्रूटमेंट फॉर्म पूछ रहा हूँ मैं, रिक्रूटमेंट फॉर्म।
नहीं अभी नहीं भेजा रिक्रूटमेंट।
अच्छा चलो मैं व्हाट्सएप ग्रुप पे डाल।
व्हाट्सएप पे डाल। चलो ओके बाय बाय।
ओके बाय एवरीवन। बाय
एवरीवन। कॉलेज में मिलते हैं ऑफलाइन में।